Hi everybody, welcome to section 7.3. Our focus today is going to be factoring, your favorite thing in the world. So one thing to remember with factoring, number one rule, always, is think about the GCF. So we always look for the GCF first, and then we'll take it from there to see what else we need to do. All right, so GCF, the greatest common factor. What do they all have in common? So we're going to go through these examples. I know there seems to be a lot, but some of them you'll do on your own, and we'll go from there and check back. All right, so this first one, 3x squared plus 9x minus 30. Again, we always look for a GCF. So what we should recognize is that they all have a 3 in common. So we'll pull a 3 out, and what are we left with? Well, we're left with x squared plus 3x minus 10. So now we'd be looking for two numbers whose product is that C value, negative 10, but the sum is going to be the B value. All right, so when we come up with those two numbers, those just become our factors. So hopefully we recognize, well, don't forget that 3 comes on down for the ride. The two numbers that multiply to negative 10 but add to 3 are going to be positive 5 and negative 2. So our factors are going to be x plus 5, x minus 2, and we're done. Okay, don't forget that 3 comes on down for the ride. Now we can do this product sum only because our leading coefficient here is just 1. If it's not 1, like our next example, we have to do a little bit more trial and error here. Okay? All right, so let's move on to our next one. All right, 6x squared plus 11x plus 3. So I'm going to zoom in here. So now, is there a GCF? No GCF. So what do we do? Well, there is a more methodical approach, and I will show you the methodical approach, but I'll also show you the trial and error. All right, so the trial and error means I know that the first two values of my factors are going to have to multiply to 6x squared. So I know I'm going to have an x and an x, okay? The last two numbers of the factors are going to have to multiply to 3. Well, since 3 is prime, I know I'm going to have a 3 and a 1 here, because 3 times 1. And eventually what's going to happen is we're going to put these factors together. So what I want to do in this first section here with these x's is I want to come up with different values for products of 6. So maybe we try 6 and 1, okay? And when we cross multiply, because that's how our factors would work. So I would have 6 times 1, which is just 6, plus 1 times 3, 1 times 3, all right? And I'm just looking at the coefficients. Well, 1 times 3 is 3, and 6 plus 3 is 9. What this number needs to be is it needs to be this middle number. Well, 9 is not 11, okay? So I know it can't be 6 and 1, so I'm going to delete those. Okay, so I need different factors of 6. So what if we try 2 and 3 here? 2x, 3x. If we cross multiply again, 2 times 1 is just 2. Plus 3 times 3 is 9. Well, that gets us 11, which is what we want. So that's good news. So what we can do is now we can group these. So we're going to group them straight across. 2x, it's got to be a plus 3. 3x, it's got to be plus 1. So our two factors, 2x plus 3 and 3x plus 1. So what did I really do? So how did we set this up? So what we notice is these values here become our first terms in the factors. And we're going to multiply those. So 2x times 3x has to get us to that 6x squared. And it does. All right? These last two values, when we multiply them, 3 and 1, they have to get us that last term. This 2x times 1, that's this working across, plus this 3 times 3x, that's this part here, that sum has to equal our middle term. So that's where these arrows come into play. So if you're able to do it that way, that's awesome. okay? If you're not, well, then I've got another approach to show you. So I'm going to delete this and I'm going to start over. Okay, the other approach is called product sum split the middle, okay? Product sum split the middle. So split the middle. So in this case, I'm looking for two numbers whose product is 6 times 3, or 18, but whose sum is the middle term here, 11. So what two numbers do we get? We should get 9 and 2. 9 times 2 is 18. 9 plus 2 is 11. So we're going to split that middle term. So it becomes 6x squared, and it's going to be plus 9x plus 2x, those two numbers that we came up with, and then the plus 3. And now what we do is we group. We group the first two, we group the second two, and we take the GCF. So GCF out of that first group, we're going to have a 3x, and we're going to be left with 2x plus 3. The second group, 2x plus 3, they don't have anything in common besides 1. So I'm going to pull a plus 1 out, and we're left with 2x plus 3. So what we should notice is these guys are identical. So since those are the same, we can go ahead and continue factoring. We can pull out that 2x plus 3, and we are going to be left with 3x plus 1, which is what we said the two factors were in that first method of the trial and error. Okay, so this is the more methodical approach. If you're more familiar or comfortable with this, by all means, use it. All right, what I want you to do now, though, is I want you to try this example on your own. Now, this is a little tricky because it's got this xy term and y squared, but I'm going to give you a second to try it, and then I'll walk through with you. So go ahead, pause the video, and factor this as best you can. I'm going to first start with the trial and error. Okay, so the trial and error I kind of started setting up. I know my first terms of my factors will be x and x, and my last terms will be a y and a y. Now, since y has a coefficient of 1, which is prime, I know this guy is going to be 1y and 1y. So what we need to do is we need to focus on the coefficient of that x term. And what we want to do is when we multiply across and add those two values, we want to get to this middle term of 6xy, okay? So we have to think about what two values that are products of 8 but will add up to 6. So hopefully you recognize, oh, if I have a 4x and a 2x, and if we were to multiply across, 4x times 1y is going to be 4xy. And then if we do this way, 2x times 1y is going to be 2xy. What do we get? Well, we add those together, we get 6xy. So that's exactly what we want. So what we can do is we can now group it, and I know it's got to be plus here because it's got to be a plus 6xy. So our two factors are going to be 4x plus y and 2x plus y. All right? Now again, if you're more methodical and you want that product sum split the middle, you'd be looking for two numbers whose product is going to be that 8 times 1, or we can think 8x squared times y squared, and the sum has to be that middle term, 6xy, all right? And so what two numbers? Well, that's going to be 2xy and 4xy. Those guys add up. So we're going to split the middle term. So we really have 8x squared plus 2xy plus 4xy plus the y squared. And now we group. First group, second group. And so we pull the GCF out of that first group, which is going to be a 2x. And we're left with 4x plus y. Second group, we can pull out a plus y, and we're left with a 4x plus y. Again, since these guys are identical, we can pull those out. So we have 4x plus y times 2x plus y. And there is our final answer. So again, whichever method works for you, use it. All right, moving on to our next example, the next group or the next 6 really are focusing on what's called difference of squares. So hopefully you remember difference of squares. So difference of squares. Now these just might be the next level of difference of squares. So if I have a squared minus b squared, it's going to factor as the square root of my first term, which is a, the square root of my second term, which is b, and then one factor is a plus, the other is a minus. So a plus b, a minus b. All right, so if we recognize difference of squares, that's how we're going to go ahead and factor. Now in terms of this first guy here, 49 minus 9x squared. Okay, well, one, it's got to be a difference, which we're subtracting here. And my first term needs to be a perfect square. It is. And my second term needs to be a perfect square. 9 is a perfect square. X squared is a perfect square. So as we're factoring it, we take the square root of our first term. So square root of 49 is 7. So I know both of my factors are going to have a 7. One's going to be a plus. One's going to be a minus. And now we take the square root of our 9x squared. Well, square root of 9 is 3. Square root of x squared is x. So we have 7 plus 3x, 7 minus 3x. And again, I should have mentioned, but we should have always checked for GCF first. Okay, so that's a difference of squares, but notice what's first. This time our constant or our number and our variable is the second term, right? Okay, take a look at this next example here. 80y squared minus 5z squared. Well, we have two terms and our variables are perfect squares, but the coefficients aren't. But what do we notice? Hopefully you notice GCF. All right, so we're going to pull out that 5, which is our common factor. And what are we left with? We're left with 16y squared minus z squared. All right, factor it fully from here. I'm going to pause the video. You should as well, and finish this problem factoring. Okay, hopefully you got the same that I got. 5 times 4y plus z, 4y minus z. Square root of my first term, square root of my second term. One's a plus, one's a minus, and don't forget to bring that GCF down for the ride. All right, go ahead and try this next example on your own. All right, 64x squared minus 4y squared. Go ahead, pause the video, try it, check back when you're done. Okay, how many people recognize the GCF first? Okay, take out the GCF first, because if you don't do it at the beginning, you'll probably forget to do it at the end. So if we take that 4 out, we're left with 16x squared minus y squared, which is still a difference of squares. So we take that GCF down for the ride. We have 4x plus y, 4x minus y. Now I did show if you didn't pull the GCF out right away, right, here's what you would have had. 8x plus 2y times 8x minus 2y. But again, this factor has a GCF of 2, as does this factor. So you would have to pull that GCF out of both of those, okay? And then you're left with 4x plus y, and then a 2 times 4x minus y. Well, then you have to multiply 2 times 2, and that's where you get that 4 out in front. So notice there's more steps, and quite frankly, we'll probably forget about the GCF if we don't do it first. So always, always, always GCF first. Make that note, okay? All right, so now I want you to move on to our next example. We'll try to go through these pretty quickly. All right, so I'll work through this one. Now, this doesn't look like anything special. This doesn't look like difference of squares, but how could we rewrite x to the 6th so it is a perfect square? Well, you might recognize that, okay, so I want perfect squares, right? All right, well, x to the what power squared is going to be x to the 6th. Hopefully you recognize that that's going to be x cubed, okay, right? Because power of a power, we multiply, and that's where we get 6. And then y to the what power squared is going to give us y to the fourth. Hopefully you recognize, well, if we have y squared, that's going to be, and when we square that, we get y to the fourth. So we can kind of rewrite this, right? So as we're coming up with our factors, remember, one's going to be a plus, one's going to be a minus, because these are difference of squares. So the square root of my first term is just going to be x cubed. The square root of my second term is just going to be y squared. And so there we actually have it. I can't factor these any further, all right? We don't have, this is a cube, and this is a square, so we can't factor that. Plus, it's a sum. This is a difference. This is a perfect square, but this is not. So this is really as good as we're going to get here. So what we can do is we can rewrite the factors, or rewrite our terms, I should say, so that they are perfect squares, all right? Okay, I want you to try the next example on your own. All right, this a to the fifth minus a cubed. Okay, see where that gets you and what you get from there. Go ahead, try it, pause the video, and get back to me. All right, hopefully you recognize the GCF. Both of these terms have an a to the third power. So if we pull that out, we're just left with a squared minus 1, which perfect is a difference of squares. So bring that GCF on down for the ride. Square root of a squared is a. Square root of 1 is 1. So a plus 1, a minus 1, and that GCF out front. All right? Okay, last one here. I want you to go ahead and see if you can factor x plus 7 squared minus 9. So what we should notice is this quantity right here is being raised to the second power, so that's a perfect square. Right? And what about 9? Is 9 a perfect square? Hopefully you say, yes, it is. So we can go ahead and rewrite this as, x plus 7 squared minus 3 squared. So now as we factor, right? My first term, square root of x plus 7 squared is x plus 7. One's going to be a plus, one's going to be a minus. The square root of that 3 squared is going to be 3, right? So plus 3 and then minus 3. So now we just have to clean this up. Okay, so x plus 7 plus 3, we would get x plus 10. X plus 7 minus 3, we would get x plus 4. So this actually factors as x plus 7 times x plus 4. All right, now what I want you to notice is, yeah, our inclination is to multiply this out, right? X plus 7 squared, figure out what that is, then subtract 9 from it and factor from there. But that's a lot more steps, and you're making room for possible errors. So you can recognize, oh, this is really just a difference of squares. So if we rewrite it as a difference of squares, then it's much easier to factor, and we get our cleaned up factors there. If you have questions, let us know.